Okay, so there are some more set of questions which you can attempt. This is the paragraph, question 14 to 16. This is the part of the previous assignment only, which we were solving in the Sunday class, discussion class. Okay, let us discuss this question first of all. So here is a complex of cobalt in which 5 ammonia ligands are there, 1 NO2 is there, and 2 Cl2 are there. 1 mole of each X and Y both gives 2 mole of AgCl. That simply means that the chlorine is out of this coordination sphere. And now we have to compare, because NO2 is the only possibility, the ligand possibility is the linkage isomerism, which should be present in X and Y. Okay, because ammonia is as it is, only the NO2 can change from its donating site. So NO2 minus is a ligand, but it can also be ONO because it is a bidentate ligand. So we are having two options, CO, NH3 whole 5. In one case, we can take NO2 as a ligand, and in another case, we will take ONO as a ligand. Okay, in which oxygen is the donor. In NO2 case, it is nitrogen the donor, and in case of oxygen, ONO, it is oxygen the donor. Okay, so one is X and another is Y. We have to judge it on the basis of their colors. So X is red and Y is yellow. So we have to actually examine the intensity of the color is brighter in the case of red. Okay. So why this intensity is being changed? Because of the linkage isomer. And why the linkage isomer is creating the difference? Because their absorption energy is different due to the donation site difference. So N is the better donor. N is better donor than oxygen. Therefore, the complex which absorbs at the higher energy will give the yellow color. Complex absorbs higher energy and gives yellow color. So in this situation, the complex which is yellow is Y, in which donor is nitrogen. So this will be Y and this will be X. By that difference, we are making the confirmation that N is the better donor. So its complex will absorb higher energy and gives yellow color, the complementary color. Okay. So by that factor, we came to the conclusion that X contains ONO minus, while Y contains NO2 minus ligand. So answer will be D. So this is the only difference by which we have to judge the complexes. So linkage isomers can have different colors due to their donation site capabilities. Which is the better donor? That complex absorbs higher energy and gives yellow color. So there are two colors given. And 15, 16 questions are comparatively easier because now X and Y both can show. We have to show that which type of isomers they can show. Okay. So NO2 and ONO are showing obviously linkage isomers, and they can also show ionization isomers with respect to chlorine. So its answer will be C. And in case of question number 16, the answer is A. Both are diamagnetic. Because it is cobalt or third complex, it will be having D6 configuration and a strong field ligand are present. So all electrons are paired, both are diamagnetic in nature. Fine. Any doubt here?
Sir, a complex emits a color of lower energy than it absorbs. I mean, counter.
Yes.
Why so?
For the color which appears is actually the complementary color of which absorbs.
I mean, absorbed energy is equal to emitted energy. No. So color should be same.
See the color, see the energy absorption is different in case of X and Y, right?
Yes, sir.
So the absorption of the energy will be higher in which case? In which nitrogen is better donor.
Yes, sir.
So it will absorb higher energy. So the color which is absorbed, being absorbed, is of the higher energy. So the color which will be reflected will be of the lower energy.
Isn't red lower than yellows?
See, the colors are given here. Na? X is red and Y is yellow. So we have to just say that which should be X, which should be Y on the basis of absorption of energy.
Red is lower energy than yellow.
Red is higher in energy. Okay. But its complementary color will be shown, which is yellow. The complex absorbs higher energy and gives yellow color. Means the absorption energy is higher in case of Y, but it is showing the yellow color, which is its complementary. Okay. The complex X is having ONO. It absorbs lower energy and gives color complementary to the higher energy. That means red. Okay, so you have to make the cases of every cation here. Okay, so we have to focus on 2 points, that the cation is giving white precipitate of a hydroxide, and then that precipitate is completely dissolved in the hydroxides only, or in the case of ammonium hydroxide also, in any one of them. So the A case will be like CD plus 2 in presence of NaOH. It will be giving CdOH2 as a precipitate. This is a white precipitate. So it will whether dissolve in NaOH or it will dissolve in NH4OH solution. So it will not dissolve in NaOH, but it will form a complex with ammonia. Ammoniated solution we will get. Right? So that precipitate becomes completely dissolved in one of the excess reagents. So in case of excess ammonium hydroxide, we will get a complex which is soluble. Okay, so A will be the answer. In case of B, chromium plus 3 in presence of NaOH, it will be giving, first of all, chromium hydroxide, which is actually green precipitate. So it will be ruled out because the precipitate we require is white in the given condition. So B is not the answer. But if it has not mentioned about the precipitate, then in presence of NaOH also, it will react and convert into CrOH4, NaCrOH4. And in presence of NH4OH also, this will form precipitate. This will form soluble complex ammonia with coordination number 4. With coordination number 6. And this will be soluble. But that green precipitate is making the difference. So B is not the answer. Again, in case of C, we will check that SnOH2 is the precipitate which will be formed. And in excess of NaOH, it will form Na2SnOH4. This will be soluble. In case of excess of ammonium hydroxide, no precipitate will dissolve. And now in case of D, BiOH3 will form as a precipitate white, but it will not further react with NaOH, nor it will further react with NH4OH. Okay. So again, C will be the answer, but D is not the answer. So correct answer will be A and C. Okay. Let us move to the next question. Okay, the correct answer is A, C, and D. A, C, and D is the correct answer. Okay. Yes, we can extract magnesium from its gaseous product, it will be obtained in the form of gas. So by rapid cooling, we can extract it, and T1 and T2 are the melting and boiling point of magnesium, not magnesium oxide. Okay. Reduction of MgO by coke is possible about T3. That is simple cases. A and C are very simple points. Here, the question is all about the confusion whether that T1 and T2 are the melting point, boiling point of Mg or MgO. That is the confusion sometimes. In the flow, we can do mistakes. So therefore, here the answer is that the phase change takes place at T1 and T2. So first it will be melting point, second it will be boiling point, and it will be of magnesium metal, not of the oxide. The graph is shown for the formation of oxide, but here melting point, boiling point is of the metal. Okay. Okay, getting the answers.
Yes, sir.
Yes, the correct answer is B and C. Okay, any explanation you need in this question? Answer is B and C are incorrect. Any case which need to be explained here?
What is PN ligands?
PN is propylene diamine. Like EN is ethylene diamine, it is propylene diamine. It will be having a chiral center. This is PN. It will be unsymmetrical ligand. Okay, fine. Getting the answers here. Its answer is 4. Anybody needs explanation here?
Yes.
Okay, see. First of all, this is a PD+2 complex, and we are having that alanine part as a ligand. So it is also having a stereo center. And in case of PD+2, this will be complexing in two manners. Like here NH2, CH3 is there, and here COO- is there. From here they are complexing it. In the similar manner, we can complex it here also. So this is one of the case we have to consider the geometry as square plane. Clear. Okay, so this is the case in which the ligands NH2 is in front of NH2, O- is in front of O-. So this is like a cis case. And we can also invert this one of the ligand from right hand side or the left hand side. It will give us a case in which O- will be here CO, CH, CH3 and NH2 from here. Okay, so these are the two cases in a general manner, but because we are having stereo centers here also, so they can also form geometrical isomers with each other, because the geometry is itself a planar till this portion. So like they will be like cis, showing cis and trans with each other also, like methyl can be same side and they can be opposite side. Okay. So in such situation, we can mark it here over here, that here it will be wedge, it will be wedge. Then one of the case will be like here this methyl will be dash. So they are also considered as the geometrical isomers, like internal cis they are, but from the leftmost and rightmost portion they are cis and they are trans. Again, similar behavior can be shown over here. Like this is outside, this is outside, so this is cis. And again, one more case can form, which is like this. Okay, so because of this chiral center, two more cases are coming. So total answer is 4, right? Equals to 4. Any doubt here now? Okay, students, let us move to the next question.
Sir, can you explain in previous question second option?
This B case,
Yes, sir.
it is optically inactive tetrahedral complex. See, BCAC is an unsymmetrical ligand. So it will be like A is the donor and again B is the donor. Both the donor atoms, or we can say that a complexing ligand having two different donors or unsymmetrical ligand, we can say. AB is treated as unsymmetrical ligand. So BCAC is actually the case in which one portion pH ring is present and methyl is present at the other portion. Benzyl acetoacetate. Actually, its full form is benzyl acetoacetate. So it is unsymmetrical ligand. So now, for now, we can write that this is B and now this is A. So no plane of symmetry will be present in this situation, or no center of symmetry is present in this situation. So this will be optically active. Okay.
So even ACAC is optically, I mean,
It
unsymmetrical.
will have plane of symmetry.
I mean, ACAC is also unsymmetrical.
ACAC means acetoacetate, and it will have plane of symmetry. No? Like it will be, in the case of beryllium, it is given like BCACAC is optically inactive. So beryllium +2 is here, and we are having AA and AA like this.
Acetoacetate, one oxygen is in minus, another is double bonded, so it is unsymmetrical.
See, it will be in the resonance hybrid. No? They will exist in the symmetrical pi distribution. So this portion is actually symmetrical by pi electron density, but unsymmetrical because of methyl and phenyl. Getting the point?
Yes, sir.
Yes. So ACAC will be symmetrical and BCAC will be unsymmetrical again. Okay, in this situation, this is MnNH3 whole 6 +2, although it is having a strong field ligand, but in this situation, that pairing of the electron experimentally do not takes place. So in this situation, T2G and EG will be filled in a general case manner. So we will be having 5 unpaired electrons over here. T2G will be having 3 and EG will be having 2. So very simple question. It is actually exceptional case. Therefore, I have taken this as a question, because sometimes we consider, because ammonia as strong field ligand, but here pairing doesn't take place. And that is due to experimental reasons, experimentally observed. Okay. Okay, come to the next question. See, if we draw the geometry, it will be octahedral, chromium present as a central atom. And now we are having 2 bidentate ligands and 2 monodentate ligands. Overall coordination number is 6. So we can write this oxalate C2O42 minus and En. Both are symmetrical ligands. So if we write here like En and oxalate like this, so here will be NO2 and here will be chlorine. This will be one of the possibilities in which we are taking that En and oxalate as cis, and automatically NO2 and Cl as cis will come. But here we can also change the geometry with respect to this chlorine and NO2. So this will be one of the geometrical isomer. So first of all, we will think about the possible geometries, then we will check for the symmetries. Okay, so these are the two cases when we are having oxalate and En adjacent to each other. Okay, Vishrut, you are getting correct answer. See, so in this situation, they both are optically active. So we will be having D and L both pairs over here. It is optically active, and it is also optically active. We are having DL pairs. But in situation where this oxalate and this En are present opposite to each other, and NO2 and chlorine can be contained in the similar plane, so they will bisect at their own position, and because they are symmetrical ligands, they will also undergo the bisection, and plane of symmetry will come over here. Okay, so you can prove for plane of symmetry over here, right? So this will be optically inactive case. So there are three possible geometries. One geometry is optically active, two are optically active. So we are getting 2 plus 2 plus 1. Total answer is 5. Okay, so its correct answer is 5. Okay, fine. See the explanation. We are having a complex CODMG whole twice. CODMG whole twice is having a geometry square planar. We'll be having a square planar geometry. And overall cobalt is +2, so it is having 3d7 configuration. And in case of that 3d7, the distribution of the electron will be like this: dxz, dyz, dz square, dxy, and dx square minus y square. This is the arrangement of the orbitals. Okay. Yes. So now if we fill 3d7 electrons, it will be like this: 1, 2, 3, 4, 5, 6, and 7. Okay. And now it has been asked that total number of electrons which are present in the non-axial d orbitals. Another condition is we have to check for non-axial d orbitals only, right? So we will be having as a non-axial d orbitals these three. Okay, these are the non-axial d orbitals, and total number of electrons are present. Counting is coming 5. Okay. They were asking number of electrons present in the non-axial d orbitals of the complex. Okay. So answer is 5.
So dz square is less than dxy only for copper +2 or all?
No, in all square planar geometries.
I mean, this happens if tetragonal distortion is very large.
See, in case of a square planar geometry, this will be followed. Okay. In case of tetragonally extended geometries, dz square is upper side and dxy is at the lower side. But for the square planar geometry, this will be the arrangement. Okay.
In JDL, they gave 2 diagrams for square planars, sir.
For square planar or for the tetragonally
Square
distorted?
planars.
For square planar only.
Yes, sir.
Okay. So in this situation, we should check for the particular complex also, na? Cobalt
They give for copper +2, dz square is always less than dxy. I mean, they mention only 3 cations.
Okay, in that situation, I'll check it. Okay, and reply is there any specific case copper +2 only, or they are just trying to say that both can be correct. So if both can be correct, then answer will change. 5 or 6 will be the answer. Okay. But I will confirm you in the next class for that. Okay. I'll
Okay.
check in JDL. No problem. Okay. You can send to me also the reference so that it will become more easier to check. Okay. Yes, one student is asking how the last compound in question 22 have plane of symmetry. See, if we draw it like this is chromium, and in this situation we are having thylene diamine as a ligand. And we are having oxalate as the ligand. Okay. And now we are having NO2 and chlorine as the 180-degree opposite case. So in this, you can simply mark a plane which will bisect NO2 at its place, chlorine at its place, and will bisect this ligand from between. Okay. Can you imagine that plane?
D options.
Very good. D.
Yes, sir.
Yes. So in this case, very simple question it is that in case of SN, the final product is not the nitrate, it is the sternic acid H2SnO3. The product is actually H2SnO3, not SnNO3 whole twice. Okay. So answer is for the incorrect case, answer is D.
Second one, C.
Yes, second one is correct. I2 plus HNO3 will oxidize it to HiO3. Please check balancing. If balancing is wrong, then also we will consider it as incorrect. Okay. Yes. Okay. So I think everyone is getting Al plus 3 as the answer. That is correct. Answer is C. Because in this case, this will be NaBr and this will be NaOBr. This is oxidizing agent, and Z not undergo reaction with, because it is oxidizing agent, so it can oxidize chromium plus 3, Fe plus 2, Sn plus 2, but aluminium plus 3 is the highest oxidation state, so C will not react. Okay, that is the reason that NaOBr will not oxidize aluminium plus 3 further. Next question. Any guesses? Any answers? Okay, Avinash is getting answer A. Raghav is getting answer C. Okay, Avinash is getting answer B. Prakash is getting answer A. Okay. See, first of all, the structure of these will be like B3O3OH3. It is the compound. We can draw it like this: BOB, BOB, and BOB, like this. And 1,1-OH is present at boron, like this. So first of all, this structure is having the 2p pi 2p pi back bonding because of this OH. Okay. And now we have to predict for the non-planar species which forms 2p pi back bond. So we have to predict about the non-planar species also. So it will be planar. It will be totally planar species. So first will not be the answer. To make the structure of B3O3OH4 or B3O3OH5 or B3O3OH6, we have to actually react this B3O3OH3 with OH minus only. So again, the structure will be exactly like common, but one boron will get OH. two OH, and other boron will get only single OH, and here B minus will be present. So it would be a non-planar species which forms 2p pi back bond due to this OH. And again, exactly similar structure will form. The number of OH will increase. Here we will get one more OH. And here we will form one more OH with one more OH. Okay. So in this situation, the fourth one will not have back bonding, 2p pi, but in this situation also we will be having 2p pi back bonding, and in these situations also. And they will be non-planar also. Okay. So basically the answer will be 2 and 3. 2 and 3 will be having the back bonding. 4 will not be having back bonding. Okay. So answer will be the second option, that means B. The correct answer is B. Fine. Any doubt over here?
The bridging oxygen will be in plane.
No, it will be like a six-membered ring, like a chair form. In this situation, we can see that it will be in the chair form. Okay.
So even first one will be in chair form.
See, the back bonding can be done from in this situation also. Okay. So the overall structure will be planar.
Okay.
And due to this tetrahedral situations, we will be getting non-planar geometry. Okay, again, students have started sharing their answers. Okay, very good, Avinash. Very good, Shrija, Vishrut, Vetrakash. Okay. Yes, the explanation. Can anybody tell the explanation for this?
Only in the case of copper, CN hold twice gas will be evolved, rest other complexes.
Cyanogen will be formed in case of Cu plus 2 only. In rest of the cases, all precipitates will be formed. Okay. Because CuCN2 will get further converted into CuCN and half CN2. And half CN2 is a cyanogen gas. So this is gas. So not produce gaseous product will be in the case of Ag, because it will form complex if we have excess, but it will form precipitate. AgCN, CdCN2, PbCN2. These will be the precipitates. And no gaseous product will be obtained. So answer will be BCD. No, Richard, in this situations, only precipitations takes place. Why you are taking them as a oxidizing nature, like Ag plus Cd plus 2 Pb plus 2 generally do not have oxidizing nature. In the case of AgCN, when they are forming precipitates especially. Okay. Some students are saying answer as AD, ABD, BCD. There are numerous difference in the answers. So take some more time. Yes, Charan, take some more time to finalize your answers. Think once again. Because this is totally theoretical point. So maybe you are missing some points. Okay. Correct statements have been asked. And first statement is okay, Shrija, Charan, Vishrut, Raghav, they given the answers. The correct answer is actually like A statement is correct. Thermodynamic stability of graphite is greater than diamond. Okay, Guru Nathan. See, first statement is correct. You can refer to the chemical equilibrium portions also. There you can or in the carbon family, we redefine it that thermodynamic stability of graphite is more than diamond, but kinetic stability is for diamond is more. For B statement, melting point of NaCl is greater than LiCl because of its ionic character. NaCl is ionic, LiCl is covalent. So for covalent characters, its melting point will be decreasing. But in case of their thermal stability, both are having ionic lattices only. LiCl is also having the lattice as a whole ionic, because Li plus and Cl minus first form their lattice and then covalent characters will be there also. So these 2 points always get mismatched. When we check for the thermal stability of LiCl, although LiCl have covalent characters, but its lattice will be ionic only. And because its lattice is ionic, it will be having more lattice energy. So the thermal stability of LiCl is more than NaCl. The reverse order is correct. In case of C, ionization energy of N2 greater than O2, because the highest occupied molecular orbital is sigma, which is also bonding molecular orbital. In case of oxygen, it is pi star, from which electrons can be easily removed. But reverse order of ionization energy is true for their corresponding atoms. Oxygen is having more ionization energy than nitrogen atom. This is wrong. Ionization energy will be more of nitrogen because of its stable oxidation, because of its stable configuration, electronic configuration. Okay, so ionization energy of nitrogen is more than oxygen. So reverse is wrong. Therefore, C is not the answer. Again, Lewis acidic strength of BeI2 will be greater than BeF2, because in case of BeF2, strong back bonding is present. So Lewis basicity nature, Lewis acidity nature decreases because beryllium is getting strong back bonding from fluorine. Okay, but reverse order is true for their melting point. See, it is also non-polar. BeF2 is also non-polar compound, and BeI2 is also non-polar. So in this situation, we will be having the molecular mass order. So the melting point of BeI2 will be more only. So the correct answer is A, B, D. C is not the answer. Okay. Is there any confusion left in this question now?
Sir, how do we speak about kinetic stability?
It is like a general statement. When we talk about stability between graphite and diamond, we first of all check the thermodynamics. That heat of formation of graphite is slightly more than heat of formation of diamond. So on that basis, we are saying that thermodynamic stability of graphite is more. But kinetic stability is because of that reactivity. Okay, so that diamond is more stable because it is very much less reactive. Therefore, on that basis, we can say that diamond is having more kinetic stability because it is very less reactive. Okay. On that basis, we are checking kinetic stability, and on basis of delta H formation, we are checking thermodynamic stability. Clear?
There you written BeF2 should be greater than BeI2, no sir, for melting point.
Reverse order is true. I have written BeI2 is Lewis acidic, more Lewis acidic than BeF2, but reverse order is true for their melting point. See, in this situation, the melting point will be higher of BeI2 only. Okay, so yes, D will not be the answer. But reverse order is true for their melting point. So BeI2 is having more melting point than BeF2. Okay, so D will be not the answer.
Sir, in JEE, BF2 is given higher melting point than BE2.
Is there any confusion here? BeF2 is having higher melting point.
Yes, sir.
Maybe because the central atom is small in size, so it will be finding it's less repulsive, right? I was also looking for that only. here you can do a correction that melting point of BeF2 is actually more than BeI2. Okay, due to the packing actually. Okay, BeF2 can more easily pack rather than BeI2. Okay, so D will be the correct case. The answer is correct. ABD is correct. Okay. So BeF2 is more melting point having BeI2 because of that packing. BeF2 can pack more easily than BeI2. Yes. Okay, fine. The correct answer is ABC. Okay. In case of copper, dilute acids do not displace that hydrogen gas, do not liberate hydrogen gas, right? So we have to find for the incorrect statement. And because for the less reactive metals, hydrogen gas do not liberate in presence of dilute H2SO4. So A is incorrect. In case of dilute HNO3, NO is actually formed, not N2O. Okay. NO will be formed, not N2O. So it is also wrong. In case of C, the copper complex, like first of all, CuCN2 will be formed, but CuCN2 will get converted into CuCN and half CN2. So the final formation of the complex will be with the copper plus 1 only. So in this situation, the complex will be KCuCN4 K3CuCN4, not K2CuCN4. Okay. So this will be also wrong. And in this situation, in case of ammonium hydroxide, first of all, it will form a precipitated CuOH whole twice. So this is correct. So its answer is A, B, C.
Sir, it will form Cu2O, not CuOH twice.
Cu2O, not CuOH whole twice. Why so? The precipitate will be formed of hydroxide only.
I mean, copper prefers oxide PPT.
But there should be some condition over here that
I
copper hydroxide is a precipitate.
mean, JDL mentions Cu2O instead of CuOH twice.
Cu2O means plus 1.
Cu, okay, no, wrong.
CuO. See,
I'll
if
check once again.
okay, if we are having that aqueous solution of CuSO4, first of all, it should form copper hydroxide, na?
Yes.
Fine.
So
In
one
it,
complex.
complex will be K3CuCN4 because
I mean,
Cu plus 1 will be the major case here. So CuCN2
ammonia
is
complex.
unstable. Ammonia complex will be in the excess of ammonium hydroxide.
If nothing is mentioned, we take it as dilutes.
Yes, we will not take it as excess because in certain cases, whenever excess is written, we get another answer. And in case of limited situation, we get another answer. So excess should be mentioned in this case, like the C option. KCN excess is given. Okay, Vishwat is getting answer A and B. Okay. So the equations we have to first of all complete. Equations will be like 2K2Cr2O7. When we will heat it, we will get 2K2Cr04 plus 2Cr2O3 and 3/2O2. This is the equation. So by that factor, we will be getting X, Y, and Z. In case of KMNO4, 2KMNO4 will give us K2MNO4, MnO2, and O2. Okay. P plus Q plus R. So we have identified them as the XYZ and PQR. These Z and R the gases. Okay. So now it will be easier to solve the question. See, that oxidation state of central metal atom are same in X and P. So X and P will have same oxidation state plus 6. Molecular weight of Z and R are same. Okay, so Z and R molecular weight are same because both are oxygen gas. Molecular weight of Q is greater than Y. See, Q among Q and Y will be having more molecular weight because it will be having 2 oxygen and 2 one oxygen more and 1 chromium more. Okay, so C will be wrong statement. The color of Y and P almost same. So it is also green in color. It is also green in color. Okay, so A, B, D will be the correct answer. Fine. Any doubt here? Okay, so you can work upon these equations again to solve such type of questions, or you can write in this form on also. Sometimes it should, sometimes it is given in the case of 4K2Cr2 7 gives 4K2Cr4 to CrO3 and 3O2. That can also be written, but to make them equally, that 2K2Cr2 7 and 2K4. Okay, fine. Let us move to the next question.
Sir, in previous question I had a doubt.
Yes.
In this above fifth one. In B option, thermal stability, NaCl has more thermal stability than LiCl. Delta HF is more for NaCl.
LiCl and NaCl, which is having more thermal stability, is LiCl, I think.
NaCl has more delta HF.
See, after formation of the lattice, during the lattice, we have to break them. First of all, they are solid. We will melt them. In that situation, NaCl will be having higher melting point. But when we will actually breaking the lattice of LiCl, the bond between lithium plus and Cl minus and Na plus and Cl minus, that will be accounted for that thermal stability. The breaking of the LiCl and NaCl as a individual molecules. A is correct. Both are redox reactions. So what are these reactions are? Like KMNO4 in the concentrated KOH, the basic medium. Okay, it will convert into K2MnO4. Okay, that will be green colored. And in this situation, water will also form. Okay. Now, P in excess of water, it is converting again into a KMnO4, and because it is less stable, and MnO2 brown. Okay, so R and S are these two, right? So both are redox reaction. This is a statement correct. Both substance S on heating with the solid KOH in presence of KNO3 reduces R. Is that so? Like a substance S on heating with the solid KOH in presence of KNO3. Will it be giving us KMNO4? Because KNO3, can it oxidize K2MnO4? That is the issue. Okay. So B is not given as the correct answer because it will restrict to K2MnO4 only. And how we can convert K2MnO4 into KMnO4? K2MnO4 into KMnO4. What are the methods?
Acidic mediums.
We have to actually oxidize them. Not this acidic medium, we will be requiring oxidizing agents.
Chlorine.
So, yes, chlorine, ozone, we can have. Okay. Electrolytic oxidation we can do here in presence of air. But KNO3 will not produce it. KNO3 is not that much capable to oxidize this compound into KMnO4. Okay, so B is not correct answer. Okay, S is converted into mixed oxide on heating. This is correct. And atomic form of Q convert I minus aqueous into I2 in acidic medium. How these are getting correct? Any guesses?
Won't we get O2 as Q?
Yes, we will be having O2. O2. Yes. Here we will be having O2. O2 as gas. Okay. Okay, so correct answers are A, C, and D. Okay, fine. Any doubt here? So basically, we have to check that the colored compound is forming K2MnO4 and then that disproportionation is taking place into R and S. Compounds, once we identify, we can solve each and every statement. See, thermodynamically feasible roasting is in the case of A, B, and D. In case of Ag2S, that roasting of the sulfide ore, that equilibrium between Ag2S and Ag2O is not maintained properly. Okay. This is thermodynamically not feasible. Only this case. Okay.
What
So
is meant
answer
by,
is ABD. Yes.
what is meant by not maintained?
Due to that, we can say that oxygen affinity of silver is very less and sulfur affinity is more. So its conversion do not takes place properly into Ag2O while roasting.
Okay, sir.
Okay. Let us move to the next question. You have to match the correct combinations and compound upon heating, what type of gases it will be giving. Okay. Some students are getting ACD. Vishrat is getting ABD. See, the correct answer is ABD only. Because PbO2 will form a PbO and half O2. Ag2O will be unstable. So Ag2O will be giving us oxygen. Magnesium carbonate will give us MgO plus CO2. Magnesium oxide is very stable. It will not give oxygen upon heating. And in this similar situation, HgO will give us HgO plus NO2. And HgO upon heating can give us oxygen. Okay. So correct answer is ABD only. In C, we are getting only CO2, not O2. Okay. Clear? Okay, guys. So can we end up here the class? Have any doubt? So there are some points at which we stuck. Let us recall those cases. Here, I think the problem was solved because the aqueous CuSO4 forms CuOH2 that is formed. And this pointer is there. I will check it again, like BeF2 and BeI2, but the correct answer is ABD only. Okay. 8th question, second option. Okay, Raghav. Question 8, second option. See, substance S on heating, the substance S is MnO2. With the solid KOH, it can convert into K2MnO4, but that K2MnO4 cannot further oxidize into KMnO4 in the presence of KNO3. Okay. So basically, that we need a stronger oxidizing agent, right? We will be needing a stronger oxidizing agent. That is the reason why it is not correct. Okay, guys. So I will check again some of the points here which we discussed and got stuck, but there are not very much cases. single one or two cases. Okay. So we can end up the class here. If you have any doubt, you can ask.